our unit number 1, that is electron ballistic. Now we have to start with the next unit, that is electron optics. So already the course material of your electron ballistic as well as optics. So all type of course material, whether it is a PowerPoint presentation, numerical bank, then theory question bank, then the course material. So all the things that I uploaded on the Google Classroom. So those who have not joined the Google Classroom, immediately they can join and they can be able to get that course material through the Google Classroom. If you face any sort of a difficulty in getting or joining, so please let me know. So that means I can be able to add that particular person in the Google Classroom. Okay, and start your preparations. And parallelly, there is one instruction already. I percolated that instruction on your Telegram group. So this is related to your scholarship. So those who are eligible for these scholarships, like maybe free ship, those who are OBC category, free ship, or maybe some reservation category, they will go for scholarship forms, and EBC also. So all these category students, they need to upload their fee receipt. Okay. So while uploading this fee receipt, so you have to upload the entire fee receipt, whichever is applicable to you. Like suppose OBC category, so it was 83,000 something. So that entire receipt that you have to upload, okay, it may be two receipt. So but these receipt with the entire fees. So whosoever having say balances, so they have to complete, because otherwise if the date get lapsed, so you will not be able to get the benefit of this scholarship or say free ship, etc. Okay, so please ensure ki you should have to complete the fees, and then and only you can upload that fee receipt on that MahaDBT website. Okay, in case of any difficulty, you can talk me after the class. Okay. Then third instruction is related to your TAE. So TAE notice has already been circulated. So that is your extracurricular. So already the topic has been also been mentioned. So please start your preparation for TAE. The last is tomorrow's. No, today's 13, right? 15th is the last date. So you have to upload these posters on your class teacher's Google Classroom. Okay. So by today itself, we will communicate the Google Classroom of all class teachers. So that means you can start uploading with your roll number should be mentioned on your poster. Okay. Your name, roll number, and division. Okay. So all these things that you mentioned. So that means we can be able to start means whatever the assessments are there, so that assessment that we will do, and we will allocate the marks accordingly. Okay. And those posters who are for the competition, means those posters whichever been selected for the competition, so they will go for the competition round then. Okay. So this is what the instructions. Now with this we will start our class. So today we will start with the second unit, that is unit number 2, optics. So unit number 2, the contents of the optics are, you can see in this particular unit that what the things that we are going to focus. One is the interference. So interference already you have studied, but here we will focus on the interference in uniform and non-uniform thin film. So optics that is this particular unit that consists of the interference, and that interference we will study in the uniform and the non-uniform thin film. Okay. So thin film is the basic concept that we have introduced in this particular unit, that is optics. Okay. The basic interference that you have studied in 12th standard, that based upon your you can say the particular medium you have chosen, or maybe it's a glass slab. So ultimately the basic thing that will remain same, but this modification that we did in this, so that is a thin film. So what is thin film and all the things that we will discuss in detail today. Okay. Then there is a second part in the unit is anti-reflection coating, that is AR coating, in short it is called as AR or anti-reflection coating. So this is a application part of the optics. Okay. So the chapter that you are going to learn is a optics under that interference. So interference, which has a very wide application in the anti-reflection coating material. So anti-reflection coating basically been used for getting the quality images. So it has been used in maybe the specs that we are wearing. So the specs lens, or maybe say lens that we are using in the cameras. Okay. So wherever these lenses are being used, so that anti-reflection coating can be used for the quality. Okay. Then there is a next application that we have to study is the surface testing. So surface testing is a very wide application in industry because the glass surfaces or the glasses they have to manufacture. So wherever there is a manufacturing of the glass surfaces or any related to your this glasses, different types of designers and all these things. So where the surface has to be tested, okay, whether there is any curvature or any there is a flaw or defect. So that thing that we can be able to test with the help of this concept that is interference. So this is a very wide application of the interference in industry as a surface testing, or it is also called as the optical surface testing. Optical because it is belong to the optics. So this is one of the important application that we are going to study in this particular unit. Then last one is the branch specific application. So branch specific, like if the person belong to a particular branch, like say mechanical or maybe civil or maybe electronics or maybe computer. So there are different branch students are there. So you have to focus on your branch key, how my branch will be related with this particular topic, how it has been related with the optics, whether it has been miss, can we think about this. So that part I will leave left to you. You can think about this, then we can have a discussion on what kind of application we can think of in a branch specific application. Okay, so these are the topics that we have to cover in this particular unit, that is optics. Okay, so with this we will start. Now you can see this slide, the two pictures that you can see, one is a peacock, another is a you can say one colorful balloon. Okay, so it's not the balloon, it's a soap bubble, and the peacock which has a different colors also, you can be able to see that different colors. So wherever we will talk about the colorization or the colors, different seven colors are there. So that may be because of the interference, or it can be a diffraction also. So these things that we can able to study under the optics. So what is optics? So optics, you can see here the definition we have mentioned here. It is the physics of light. Optics basically is the physics of light with different layers of understanding or describing light. So physics of light. So wherever the light concept, so that I studied under one head, that is called as optics. Okay. So physics of light, that is the optics, and the different layers of understanding or describing the light. So how we can be able to understand or describe the light, whether it travels in a particular medium or maybe different medium. So how it will travel. So all these types that we can be able to study under the head of optics. So that is the optics. Okay. So basically, what is optics? If you say so, optics is a physics of light, and where we describes or understand the light. Okay. So this is what the optics. So with this, we can be able to start. Now, this is a very important chart of electromagnetic spectrum. So everyone should know this thing. Key what exactly? So you can see here is a, I mentioned is a reminder because already all these things has been done by all students in 12th standard. I expect key everyone know this thing. So here is a visible light is a very small part of the electromagnetic spectrum, as you can see in the this diagram. So very small part. So electromagnetic spectrum which has a very wide range, and among this range there is a small part that is a visible wavelength. So what is the visible wavelength? So I mentioned here it is in the range of 400 nanometer to 700 nanometer. So 400 nanometer to 700 nanometer is the range for the visible light. Okay. So as you know that 400 nanometer that correspond to the violet color, and the 700 nanometer correspond to the red color. Okay. So that is the means visible wavelength. Visible means we can able to see this particular range. So if any color that you are getting between this 400 nanometer to 700 nanometer, so that color we can be able to see or visualize with our eye. Okay, so that is called as the visible spectrum. And above this and below this, so there are different range you can see here. So if you go below the 440 nanometer, so 440 nanometer, that is the ultraviolet radiation. Okay, so it means the last range for the visible is 400 nanometer, and if you below that 400 nanometer, so it will be a ultraviolet, and if you cross the 700 nanometer, so it will be infrared. and then further there is another one, means after the ultraviolet there is a x-rays, then gamma rays, then x-rays there is a classification, that is soft x-rays, then hard x-rays. Then if you cross the infrared, so there is a terahertz, microwave, and the radio spectrum, means whichever the broadcasting or wireless communication that happens in a radio spectrum range. Okay, so because there is means the disturbance level is very less. Okay, so these are the what we can say is the electromagnetic spectrum. So you should know, because this is a basic question that can anyone can ask you ki what is the visible range. So visible range basically is the 400 nanometer to 700 nanometer, and the minimum is the 700 nanometer is the violet color, and 400 nanometer is the violet, and 700 is the red color. And if you cross these limits, like if you below the 400 nanometer, it will be ultraviolet, and if you above the 700 nanometer, it will be infrared. Okay, so that is not in our range. Got it? So this is what the electromagnetic spectrum and the visible range. So you should know these things. So that's why I mentioned this particularly, because we are starting the optics. So optics, we are focusing on the light, and the light here we are focusing on the visible light presently. So visible light is the range which is between 400 to 700 nanometer. Okay. Now the next, now, as we have to start with the interference, so everyone should know what is superposition. So, superposition means what? So, to understand the superposition, we should require minimum two light waves. Okay. So, here we can see there are the two light waves, and these two light waves they've been added together. So, added means what? So, it is not like it means simply 1 plus 1 is 2. So, it is a resultant of these two. Okay, so resultant means their amplitude get add. Okay, so you can see here the statement we have mentioned, superposition. So if two waves occupy the same space, their amplitude add at each point, they may interfere either constructively or destructively. So constructive and destructive, that is a concept of interference. But thus what is basic superposition? So that is simply addition of the two light waves. So addition of these two light waves, that gives you the resultant wave, and that resultant wave can be a modified form, that is modified in the sense if it is in a magnified form, so enhanced manner, so that we can say constructive. In that case we can be able to get the condition for brightness. And if they intersect in a opposite direction, so like opposite in the sense you can see in the c diagram number c. So in this case one wave is in phase and another is out of phase. Okay, so if these two waves they intersect, so the outcome that comes out to be a straight line, means amplitude become zero. In A or B case, you have seen the amplitude becomes maximum if you compare with the previous two waves. So when the amplitude become maximum, so that is the constructive interference, means you are getting a more brightness. And when the amplitude becomes means it satisfies the destructive interference, so amplitude is zero. So zero amplitude means there is a complete darkness. Okay, so in this way, the interference that we have studied in 12th standard. See, in 12th also you have mentioned with respect to the crest and the turf. So when the crest is coincide with the crest and the turf is coincide with the turf, so you can get the point of maximum that we call as a condition of brightness. Okay, so in that case, if you say amplitude is maximum, so naturally the intensity will also become maximum, because amplitude and intensity are correlated. So I, that is intensity which is proportional to amplitude square. Okay, so if you say amplitude is 2, so your intensity become 4. So if the amplitude is 4, so intensity becomes 16. So in this way, if the increase in the amplitude, so naturally there will be increase in the intensity also. Okay, so here intensity can be increased by satisfying the condition of constructive interference, and if you want to low down the intensity, so that will be a destructive interference. Okay, so in this way the interference. So now what could be the minimum condition to get this constructive and the destructive interference, so that we will be able to focus here. So these are the conditions. So the condition for interference, so everyone know about this, but we'll just try to recall what are these conditions. So see, the following four condition must be true in order for the interference pattern to be observed. Okay, so how you can be able to get the interference pattern? So first is the source must be coherent. So how you can be able to get the coherent sources? Because minimum requirement is at least we should have a two light waves. Okay, so how you can be able to get these two light waves? Okay, so if these two light waves are originated from the single source, then we can say these are the coherent. Now what do you mean by the coherent? So coherent means it should have a same amplitude, same wavelength, they should have a same phase difference or maybe constant or zero phase difference. Okay, so that these are the mandatory condition for getting the coherent waves. Okay, or the coherent light. Okay, so coherent here, the source must be coherent. So source, we are talking about the source. So source means what? The light source. Light, it can be a yellow light source or any other source which has a only single wavelength. Okay, so even though we talk about say yellow light, so yellow light is considered as a monochromatic, but still yellow which has a doublet means sodium D1 and sodium D2. The wavelength corresponding is 5890 angstrom unit and 5896 angstrom unit. So while taking observations or doing calculation, we consider the average wavelength, that is 5893 angstrom unit. Okay. So this is a mandatory condition key the source must be coherent and has a constant phase relationship. Constant, it means either if it is zero, so both the waves or both the sources should have a zero phase difference or maybe a constant phase difference. Okay. Then second mandatory condition is wavelength must be same. As I mentioned, the wavelength is a mandatory part. So mandatory, it means here wavelength is monochromatic. Here you can see here mono. Mono means single and chromatic means color. So if your particular source which has a single color, monochromatic, then we can say that single color means single wavelength. So it corresponds to a single wavelength. Got it? So please try to remember the monochromatic means having single color. Okay. So that is the second mandatory condition to get the interference pattern. Okay, the first one, I repeat, the first one, the source must be coherent. Okay, and what do you mean by the coherent? So coherent means which has the same amplitude, same wavelength, and they corresponds with the constant phase relationship. Okay, so constant means it can either be zero or anything else, that should be a constant. Okay, so depend upon whatever the phase is being introduced, it may satisfy constructive or it may satisfy destructive. But that is the condition that we need to satisfy. They should have a constant phase relationship. Okay. Then the third one, the principle of superposition must apply. So that is but natural, you can say, ki if the two waves they intersect with each other, so they should satisfy the condition, that is principle of superposition. Okay, so principle of superposition that gives you the resultant of vector addition of these two light waves. Okay, it is not simple addition, it is a vector addition. Okay, so how the particles are moving in a one particular or other direction, so all these directions are also been considered, so therefore it is called the vector addition of the light waves. So that is possible through the principle of superposition. Okay, and then lastly, the waves have the same polarization state. As you know, the polarization means it's 100% coherent light waves. Okay, so 100% light waves, and we can be able to identify the types of vibration through the polarization. Okay, so polarization is the only concept through which we can say कि the vibrations of the particle are in one particular direction or it may be in another one. So for this, what the condition is, ki your amplitude should be same. If the two light waves have the same amplitude, means they are in a coherent mode and they intersect in a linear direction, so they can be able to get the maximized polarization. That will be, we can say, the intensity maximum. And then second case, if these two waves have the same amplitude but they differ by an angle of 90 degree, so in that case, if they intersect, so their vibration will produce a circular polarization. Okay, and if we say these two waves have some differ in the amplitude as well as phase, so other than 90 degree, if they have some different phase, so and they start interacting with each other, intersecting with each other, so in that case they can be able to produce a elliptical polarization. Okay, so this is what the polarization states are there. So how the types of vibration, so that also matter while satisfying the condition of interference. Okay, so all these 4 points that you have to keep in your mind, key the if we satisfy this condition, then and only we can talk about the interference. Okay, so the most important condition is the current. Okay, so whichever the two light waves you are selecting, these two light waves should be current. Okay, and coherent, it means they should have same amplitude, they should have same this phase difference or phase relationship, and they should have the same wavelength, that is monochromatic. Mono means single, chromatic means color. Okay, and they then these two ways they satisfy the principle of superposition to get the condition of maximum or the minimum. Okay, so this is what about the interference. That's this part already you did in a 12, just revision. Then next is the conditions. So as you know, the condition of constructive and destructive interference. So I'll just mention here. You can just see a diagram. So what is the condition? So here, as you have learned, the conditions for interference for constructive as well as the destructive. So just look at the diagram. So what the diagram says here. So in first diagram, you can see these are the progressive waves. Okay, the progressive wave. So in first diagram, you can see the two waves intersecting, and there is a red mark also, red color wave. So that gives you the resultant of these two. So resultant means what? If these two waves they intersect, means this blue color you can say. So if these two waves they intersect, so their part difference is integral multiple of the wavelength. Okay, if there is a part difference of integral multiple, or it can be zero, so it means your n value will start from 0, 1, 2, because the equation that you have studied in 12th standard, that is part difference, which is equals to n lambda for condition for brightness. So n equals to 0. So in that case, you can be able to get the maximum. Okay. And then second is destructive, means when the part difference is odd integral multiple of the half wave. Okay. So in that case, we can expect you can get the minimum intensity. So here a red line you can see that it comes with the minimum intensity. So this is one diagram that can give you the idea about what is constructive and the destructive interference. Okay. Then now the most important part here is the methods of interference. So how we can be able to get the interference? So there are the two methods. So one method already you have studied. Yes. Okay. Now look at this slide. So method of interference. So there are the two methods that we have mentioned in this slide. One is division of amplitude, and second one is a division of wavefront. So division of wavefront already been familiar with all of you. One is the Young's experiment. Okay. So Young's experiment and the biprism. So Young's experiment, what we did and why it is called as the division of wavefront. So hopefully you can be able to understand. In Young's experiment, what we consider is a point source, and the point source that generates a spherical wavefront. Okay. Hello. Am I audible to everyone?
Yes, sir. Yes, sir.
Fine.
Yes, sir. Yes,
Okay.
sir.
So
Yes, sir.
we are discussing on the methods of interference. So in the method of interference, there are the two methods that we have mentioned in this slide. The two methods are, one is the division of amplitude, and second one is the division of wavefront. Okay, so we'll start with the second method, then we'll move to the division of amplitude. So because this entire unit that based upon the first method, that is the division of amplitude, that is thin film. So I have not started with the thin film yet, but we'll just revising the your 12th. So here the division of wavefront. So what does it mean by the division of wavefront? So simple example, everyone know the Young's experiment. So in Young's experiment, what we did, so we have considered a point source, and through that point source, the wavefront, which is a spherical form. Okay, and in front of this spherical wavefront, we have placed one cardboard, and through that cardboard, we had a two pin holes, and that become a two secondary sources. Okay, or From these secondary sources, we have the wavefronts also. So there are two sources, S1 and S2, which is generated from a same source, that is S. Please try to recall your Young's experiment. We have formed the two sources S1, S2 through the same source, that is S. So getting the two sources from a same source, that is a coherent sources. Okay. So that is the mandatory condition of interference. So that we have studied in the 12th standard key how a single wavefront is divided in a two wavefront. So that is the condition of division of wavefront. Okay. Similarly, in biprism also, by getting a virtual images from a single image, that is incident beam, we can be able to get the two images. Okay. So that is a biprism experiment. So these experiments that already you are performed in a 12th standard. Now I will focus on the division of amplitude. So to understand the division of amplitude, first we have to understand the thin film. So what is thin film? Because the entire chapter or the unit is based upon the thin film. So any rough idea, anyone? What is thin film? Anyone can say? No one? Okay. So thin film basically a film whose thickness is of the order of one wavelength of visible light. Now you know what is the wavelength of visible light. Wavelength of visible light is 400 to 700 nanometer. So if you take the average of these two, so it comes out to be 550 nanometer. Okay, so 550 nanometer, that correspond to the green color. So while taking any observations or performing experiment, we consider the average wavelength, that is 5500 angstrom unit or maybe 550 nanometer. Okay, so when if we talk about the thin film, so particular film whose thickness is of the order of this 5500 angstrom unit, then and only that film is considered as a thin film. Are you getting? Okay. So thin film is what? A film whose thickness is of the order of one wavelength of visible light. One wavelength of visible light. And that wavelength is 5500 angstrom unit. So that film will be considered as a thin film. Okay. Now, there may be question in your mind, ki what about the other then? If it is not in that range, so can we consider that as a other film? So answer is there is another way of identifying. So that film we call as a thick film. So not every type of material or every sort of thickness will be considered in a thin or thick film. So thin film has a particular definition and which consider only a visible light wavelength, one wavelength of visible light, and that wavelength is 5500 angstrom unit. Then and only that film will satisfy the condition, otherwise not. Okay, so you should have to be very particular about this thing. Key wavelength. So wavelength should be a one wavelength of visible light. Okay, then thick film. So thick film is a particular film whose thickness is of the order of 10 micrometer to 50 micrometer. So you can imagine our human hair, which is also of the order of say 50 micrometer, as well as aluminum foil or say silver foil. So these foils are of the order of say 50 micrometer. So such type of film can be considered as a thick film. Okay, so thick film range is between 10 to 50 micrometer. 10 to 50 micrometer is the range for the thick film. And if the film which is of the order of 5000 to 5500 angstrom unit, so that will be thin film. So now what are the examples of thin film? So thin film can be air film or soap bubble. Okay, air film or soap bubble whose thickness is of the order of 5500 angstrom unit. So that film considered as a thin film. Okay. Now we'll come to the part of how we can be able to get the two coherent light waves through division of amplitude. Okay. So this is the method that we have to apply in case of interference. So look at the diagram here. So what the diagram says here, key there is a plain glass plate at the bottom, that is AB, and above this glass plate there is a plano convex lens. Okay, now why it is called the plano convex lens, you can see here one surface is plane and the convex part is at the other end. Okay, so this plano convex lens which is placed on a surface AB, that is plain glass plate, you can say. Okay, so there is a plain glass plate AB at the bottom, and at the top there is a plano convex lens. So one surface means there is a point of contact, that is point O. So at point O, the plano convex lens and the plane glass plate, they make a contact with each other. Okay. So please try to understand, this diagram is only for our understanding purpose. Okay. Because if you think about it, there is a huge gap which has been formed. So it is not like, so that gap is very minimum that we cannot be able to see with the naked eye also. Okay. So that much is the gap. So you can see there is a gap which has been formed from the sideways. So point O is the point of contact, and at the side there is a gap, and this gap which is filled up by the air, and that air which satisfy the condition of thin film, because it satisfy the condition means what? Its wavelength correspond to 5500 angstrom unit. So therefore this thin film is considered as a air film. Okay, so at the sideways whichever the gap is there, so that gap which is filled up by air medium, and that air medium which is also called as the air film. Now why it is air film? It is because it satisfy the condition of thin film. Okay, so therefore it become a air film. Is it clear to everyone? So, what is thin film? So, thin film, please try to understand. Once again, we'll revise if you are not getting properly. So, what is thin film? So, thin film, already we have defined key if a particular wavelength whose means a particular thickness whose wavelength is of the order of one wavelength of visible light. If it satisfy one wavelength of visible light, then and only we can call this other thin film. So here, for to understand this, we consider a plain glass plate, and above this plain glass plate there is a plano convex lens which is mounted. Okay, so due to this mounting, there is a point of contact where the plain glass plate and the plano convex lens, they make contact. So that contact point is O, and because of this, the sideway is the air, means the gap, and that gap which is filled up by the air, because nothing is there, it means there is air. Okay, so there is air, so there that gap which satisfy the condition of thin film, so that become a air film. Okay, so in this case what we did, we are incident a beam of means the light beam, that is say incident beam is a CD. Okay, so there is a single light beam which is incident on this surface of plano convex lens, and after once it incident, so there is a partial action, it get partly reflected and get partly transmitted. Okay, so after partly reflection and refraction, it forms a ray 1 and the ray 2. So ultimately what we did here, we are incident a single beam and we are getting a two reflect, means the two rays, one ray 1 and the 2. So these two rays are originated from a single ray, so therefore they are called as the coherent rays or the coherent signals or the coherent sources. Okay, because it may work as a source also later on. Okay, so basically these rays are nothing but in the form of waves. Okay, so they comes in the form of waves and they incident on this surface. So waves which has a particular amplitude, so once it will struck on this surface, okay, so there is an amplitude which get divided in a reflected and the transmitted part. Okay, so therefore it is called as a division of amplitude. Okay, so amplitude, because all these rays are nothing but in the form of waves. Okay, I will just show you one more diagram. Look at this picture. So here, this is your incident wave. So what we said ki that ray, so that rays are nothing but a waves. Okay, so these they comes in a form of waves, and that amplitude that get divided. So one will be a transmitted, another will be a reflected, like, okay. So the two rays are being formed, okay. So in this way, so these rays are nothing but a particular waves. So these waves are coming with a crest and the top, okay. So your amplitude basically is divided in a two parts, okay. So which these two parts means they form one as a reflecting ray, that is ray 1, and the another is the transmitted one, that is ray 2. So these two rays that has been formed, okay. So one means two rays we are getting from a single ray, so therefore these are called as the coherent rays. Okay, we'll come back to our diagram. So here, so therefore the method is called the division of amplitude. So please try to read the division of amplitude. What does it say? So this involves the splitting of a single light beam into the two beams, a reflected beam and a transmitted beam at a surface between the two media of different refractive index. Okay, so simple answer, because reflection is in the same medium and refraction is through the different medium. Okay, so here there is both the things are happening. If you are getting a image or the ray from the reflection, so that will be a miss from the same medium, okay, because it will incident on the surface, so it get partly reflected and get partly transmitted. So due to this partial action, so it forms a two rays from a single ray. So that method we have called as a division of amplitude. Okay, so simple, it is also clearly mentioned ki splitting of single light beam into the two beams. One is because of reflection, another is because of transmission. Okay, please try to clear all this concept ki how we got the two rays from a single ray. So that is the mandatory condition of interference. Okay, so these things that we are studying through the thin film. And what is thin film? That also we have focused. Thin film means a film whose thickness is of the order or about the order of one wavelength of visible light. So if you satisfy this condition, then and only we can call that film as a thin film. Okay. So this is what about the beginning of this particular unit. Then there is a important topic that we can be able to start: interference in uniform thin film. So uniform thin film is how we can be able to study the interference concept through the uniform thin film. So that is been given in this particular figure. So you can see what the figure says here. Here the two dark lines I have mentioned. So dark line that indicates a particular film. Okay, so that has been given by some different color, that is a blue color, and whose refractive index. Okay, so which has a particular refractive index, and above this film there is nothing. It means there is air, and below this film there is nothing. That is air. So this film having a thickness T. So what you will consider here? So when you will write your answer, so you will say consider a plain parallel thin film. Okay, what you will write here? Consider a plain parallel thin film of uniform thickness, that is T. Uniform thickness means what? So the T that starts from one end to other end. Okay, so everywhere you will see the thickness that remains same. Okay, so therefore it is called the uniform thin film. Okay, interference in uniform thin film is what? We have kept the thickness. So these this particular film that we have chosen, so which has a particular thickness that range from one end to the other end. Okay, so it has a constant thickness, so therefore it is called as the uniform thin film. Okay, so that is your first statement for this key. We have considered a plain parallel thin film of uniform thickness, that is T. Okay, is it clear? Then next, now you can see there is a ray which incident on this uniform thin film. So what you can say here, let a broad monochromatic source of light is incident. Okay, so broad monochromatic, why I consider the broad monochromatic? So it is because it is not possible to incident a single ray. Okay, but Again, I repeat ki these diagrams are only for our understanding purpose. Okay, we will not be able to incident a single ray. So therefore, you while writing, you will mention ki it's a broad source of monochromatic light, and through which one single ray that is incident. Okay, so in that case, so this ray that incident obliquely. Now obliquely means what? As you can see here, oblique means it makes certain angle. Okay, once this ray that incident on this thin film area, so it incident with the means there's a, you can see here, it makes the angle of incidence, and then after that it get reflected and it forms a ray 1. Okay, so ray 1 undergoes a phase change on the reflection. So there is a phase change that we have mentioned here. So phase means the phase that correspond to the pi. So there is a pi change because it get reflected from the denser to rarer medium. As you can see, air which has a refractive index 1, and the film that we have chosen which has refractive index greater than the air medium. Okay, so therefore the film which will be considered as a denser medium and air will be your rarer medium. So your light ray which incident on the denser medium and it get reflected from the denser to rarer, means the reflection happens in same medium but reflection from the denser surface. Okay, so therefore some part of this ray that get absorbed and that part correspond to the half of the wavelength. So therefore there is a phase change of pi radian, or maybe you can say the 180-degree phase change. Okay, so please try to understand this concept properly. Ki what we did here, ki we are incident a beam, and once this beam is incident on the surface of the film, as the film which has a particular refractive index which is greater than the air medium, so therefore it's a reflection from denser to rarer medium, so it gives a phase change of 180-degree and it forms a ray 1. Is it clear? Okay, now next. Now how can we be able to get the ray 2? So ray 2, you can see, I'll just go for previous one. Ray 2, so does not undergo a phase change on reflection. Now you can see, so once this ray will incident on the surface, so there is a partial action, it get partly reflected and it forms a ray 1, and get partly refracted and there is an internal reflection. You can see there is an internal, means it is in the same medium. So at this point there is no phase change because it is in a same medium. Okay, means it reflect from the denser and it is in a denser medium only, so there is no phase change. But that is not the case in previous one. There is a reflection from denser to rarer medium. Okay, please try to understand these two concepts, it is very important. So in first case there is a phase change that is 180-degree, and in second there is no phase change. Okay, is it clear? Then it forms a ray 2. Okay, then it will come out and it forms a ray 2. Okay, is it clear to everyone? Ki how we can be able to get the ray 1 and ray 2 from a single ray. So that is the main part in this particular interference in uniform thin film. Okay. So once again, what we are consider here, so we are consider a plane parallel thin film of uniform thickness, that is T. Then afterwards, what you will write? Let a broad monochromatic source of light incident obliquely. Obliquely means it makes certain angle of incidence. Uh, then you will say the ray is partly reflected, means the incident ray. You can label this by some number or alphabets. Let's say AB. Okay, say AB is the incident ray that will incident, and once it incident on the film surface area, so it get partly reflected and it forms a ray 1. Hello, and partly get transmitted and it forms a ray 2. Okay, so this is what we have to write initially. Okay, now the next. Now, there is a question like, do the refracted rays 1 and 2 interfere destructively or constructively? So, how we will say whether it will intersect, because the rays that are coming, that is ray 1 and ray 2, these are the two parallel rays. Okay. So, are they going to intersect? That is the first question. Are they going to intersect? And if they intersect, so whether their intersection will produce the constructive or maybe say destructive interference. So to understand this, so we have to find out the phase difference between the ray 1 and ray 2. Okay, so we have to identify what could be the phase relationship. So you have to apply the, so ultimately first of all, what we can conclude here, ray 1 and ray 2, which is originated from a single ray, so therefore these two are the coherent rays. Okay, so that we have the condition of interference. Now after getting these two rays, that is coherent rays, now we have to get the phase difference between these two, so that we can be able to get the condition for constructive as well as destructive interference in case of in uniform thin film. Okay, so the caution here, the wavelength in the film is different than in air. So that is a caution. Okay. Now you can see here the wavelength which is mentioned, the for film, that is lambda, which is f film, which is equals to lambda by n. Okay, so there must be some refractive index, so therefore it is mentioned clearly. Okay, so it is other than air. Now you can see the path length difference between is approximately twice t. Okay, so twice t means the rays which are traveling through the film area, so that is a geometrical one, that is twice t is a geometrical. So there are the two concepts. One can be a geometrical part difference and there is an optical part difference. Whenever we talk about the geometrical part difference, so that will be a physical measurement. And if it is an optical part difference, so there will be a refractive index that will come in the path. Okay. So the geometrical part difference between the ray 1 and ray 2, that we can be able to find out, and then we can correlate this path with the optical part difference. So if you can make all the calculation, so what the values that you will get, please try to understand here. So there is a phase difference of 180-degree and the half wave, because once these wave that will incident on this, so half part of the wave that get absorbed. Okay, so we'll just move ahead so that you can understand. So half part of due to this first reflection, so we will get the destructive interference when the part difference is integral number of the wavelength. Okay, so as you know, the condition for destructive interference when the part difference is integral number of the wavelength. We will get the destructive interference when the part difference is integral number of the wavelength, and the condition that we will get is twice t, which is equals to m lambda. Okay, so if you can be able to get the condition that is 2t, which is equals to m lambda, then we can be able to get the satisfaction is 2n t, which is equals to m lambda, and m value that varies from 0, 1, 2. So if you substitute this value, so first value that comes out to be a 0, then 1, etc., 1 lambda, 2 lambda, etc. So in this way you can be able to get the integral numbers of wavelength. And then if you get the constructive interference when the part difference is lambda by 2 or 3 lambda by 2 or 5 lambda, so it is, now you can see how the condition has been changed. So here the conditions that we are getting, that condition is exactly opposed to your condition that you have studied in the 12th standard. Okay, so condition as you have studied in 12th is the constructive is the integral multiple of the wavelength, but now here that condition become the condition of destructive, and here the condition for constructive interference that become an integral multiple of half the, this odd integral multiple of half the wavelength. That was earlier the condition for destructive, now it become a condition for constructive interference. Okay, so these are the modified conditions, means we have modified by taking the previous condition of interference and we have applied that to the thin film, and then we got this modified conditions. Okay, so please try to understand these are the modified conditions, so that means you don't get confused between the previous and the last one. Okay, so we can have a complete derivation of this also. So we means how we can do to get these conditions. Okay, For constructive interference it is 2t which is equals to m lambda, and then destructive interference 2t which is equals to m plus 1 lambda. Okay, so it is not mandatory that here I mentioned say m, so you can use say n also, there is no problem. Only the notation to be properly mentioned in the diagram, ki m or n whatever it may be, but it should start like here. In this case m start with a 0 1 2, so here also m that should start with a 0 1 2 only. Okay, if you say m minus 1 lambda by 2, so that will start with m 1 2 etc. Okay, so these conditions that you should have to remember properly. Okay. Then finally, the condition for bright and the dark ring. So condition, the optical part difference that is denoted as delta. So this optical part difference between the ray 1 and ray 2 can be written as delta, which is twice mu t cos r minus lambda by 2. So from where we got this equation, so for this I will show you the derivation entirely, because right now we don't have that much of time. So maybe in the next lecture we can have an entire derivation. Okay, so delta which comes out to be twice mu t cos r minus lambda by 2. So here you can see as the medium that we consider is air. So for air medium, mu is equals to 1 and cos r is equals to 1 for normal incidence. Now what is cos r? So cos r, here you can see the for normal incidence. So if you consider the incident beam which is incident normally in the sense it is exactly perpendicular to the surface, so there is a back reflection, means it get directly back reflected. Okay, so therefore your angle of incidence I, that becomes, means it is incidenting at the zero position, so your r becomes 0, so therefore cos r become 1. So therefore here clearly mentioned when if the medium is considered as air, so mu is equals to 1 for air medium, and for normal incidence cos r is 1. So therefore your delta that comes out to be twice t minus lambda by 2. So for maximum the optical part difference delta that comes out to be means that already we have studied for maximum, that this is your 12th. Now delta which is m lambda means integral multiple of the wavelength. Now you equate these two equations, so you could be able to get the equation that will be for the constructive interference. So it is an integral number of full wave. Then the rays meet each other in phase. The crest of one wave falls on the crest of the other, and the waves interfere constructively. Okay. So this was the conditions that is been derived one. And then if you consider say 2t minus lambda by 2 equals to m lambda, so you will get the 2t which is equals to 2m plus 1 lambda by 2. You can see the refer the diagram. So here 2t minus lambda by 2, one delta, and the another delta that we had, that is m lambda. So if you equate these two equations, so we will get, after equating, that is 2t minus lambda by 2 equals to m lambda. And from this, what is 2t, which is, so all this lambda term which is shifted to one side, so twice t which is equals to 2m1 2m plus 1 lambda by 2. So this is the condition that we can call as a modified condition for obtaining the bright fringe or say bright ring. Okay, and then delta comes out to be 2m plus 1 lambda by 2. Okay, so the minimum condition occur when the optical part difference is delta, which is 2m plus 1 lambda by 2. Okay. The optical part difference between the two rays is equal to the odd integral multiple of half wave. Then the rays meet each other with the opposite phase. So the crest of one wave fall on the top of other. The waves interfere destructively. So this is the condition that already we have studied in the 12th for destructive interference. Now you also equate this condition with the help of this delta, which is 2m plus 1 lambda by 2. So you can see, okay, one point is missing here. So just you have to equate this, so you will get the answer in a same manner, that is twice t, which will come out to be m lambda. Okay. So ultimately, the things are very difficult to understand here right now. I will show you the entire detailed expression. See how we can be able to get this all stepwise. Okay, so we'll try to conclude. Uh, the concluding is here we are discussing on the interference in uniform thin film. So in uniform thin film, you can see ki, we are consider a uniform thin film of thickness that is T. Okay, and on this uniform thin film, we are incident the beam of means the light beam, and which is in a form of a broad source. Okay, so it's a broad source of monochromatic light. Once it incident on the surface of film area, then there is a partial reflection and the partial refraction. So due to this action, there is a two rays which has been formed, that is ray 1 and ray 2. Okay, and these two rays are originated from a single ray, so therefore they are being called as the coherent rays. Okay, and the ray 1 which is reflected from the denser to rarer medium, so it includes a phase difference of 180 degree, and the ray 2 which is internally reflected, so therefore there is no phase change. Okay, so these two rays are being formed from the reflection. Okay, so after which what we did, we have identified the part difference and the phase difference between these rays, and then we have derived the condition for constructive and the destructive interference. Okay, so now what is the derivation part, that we will do later on. Okay, so this is what today. So things are little bit difficult to understand here, but try to understand, and wherever you feel doubt or difficulty, please raise that questions also. Okay, so okay, so here we will stop, and from next time, everyone please try to join with your roll number. Those who are not joined with the roll numbers. Okay, so thank you very much. Thank you.